So given this example now, we are given that we must find, or rather simplify this equation in terms of A, right? So now the best thing to do at this point in time is to guys, I just need this. Okay, can you guys see, like, can you guys see my face?
No, I can't. But I think it should be okay as long as we can see what you're saying.
Okay, I'm thinking for the sake of consistency, let me just show face because I've been doing that like since.
Okay.
Yeah, let me just show face. I think you can stop with this recording. You can stop and then record again.
It's fine. We'll crop it out.
Okay.
I think so. What do you think too? Yeah, it's okay. We'll crop it.
Okay. No, not a problem.
Okay.
Let me just quickly enter this on my laptop. You guys can see me now, né?
Yes. Yes.
Okay, great. So we are given this example. We are given this problem to solve. So you're going to solve the equation rather. Solve the equation in terms of A. So now we are seeing that we're dealing with an awkward angle that, okay, let me just include this without using the calculator. Very, very important, without using a calculator. So when you're presented with such and you're told not to use a calculator, the first thing that you want to try and resort to is the information that's given to you. So we are given that sine of 31 is equals to A. So at the end, we must find something that will help us to find the sine of 31 degrees. So now, if you look at this and write it in terms of the reduction formula, this expression in terms of the reduction formula, it's just equals to the tan of 108 degrees plus 31 degrees, which just gives us the 211. And then you're going to multiply it by cos of 180 degrees plus 31 degrees. So we have that. And then we know that 180 plus 31 degrees lies in the third quadrant. So when it lies in the third quadrant, we can say that in the third quadrant, we know that tan is positive. So this is going to be reduced to tan of 31. And then times, okay, we know that cos in the third quadrant is negative. So we're going to say that is just equal to the minus cosine of 31 degrees. So now we can further remove the brackets by saying it's just tan of 31 degrees, the cosine of 31 degrees. Sorry about that, guys. All right. Yeah, this should be good. And then the tan minus the tan of 31 degrees times the cosine of 31 degrees. So now we can write the tan of 31 degrees in terms of the sine and cos, because this is the same as just writing the sine of 31 degrees over the cosine of 31 degrees times, let me just write it explicitly, times the cosine of 31 degrees. And then now we know that this can cross divide, and then you're going to be left with minus the sine of 31 degrees. But we also know that the sine of 31 degrees is just equals to a, and then you can write it as such. So now we've achieved writing this expression over here in terms of a, which is just minus a. So I'm just going to quickly move forward with this. Just quickly move forward with this. And do yes, just other problems. So just do this. So now we are going to simplify P to a single trig ratio. So you're going to say P is equals to the sine of 360 plus theta cosine of 180 plus theta, and then the tan of 360 plus theta. Just take it as theta, guys. So I just run out of space. So we do know that the sine of 360 plus theta, and theta, given that theta is always an acute angle in this context, it's always an acute angle. So we can say that this falls in the first quadrant because 360 degrees is a revolution. And in the first quadrant, all the trigonometric ratios are positive. So you're going to have it as sine of theta. And then the cosine, and then 180 plus theta falls in the third quadrant. So the third quadrant, we know that only tan is positive, which means that all the other trigonometric ratios are negative. So you're going to have this as, okay, it's minus cos. So I'm just going to put minus here, and then the cosine of theta. And then the tangent of 360 degrees plus theta, which is this one. I'm sorry, it's not visible. The tangent of 360 plus theta is just equals to the tangent of theta, because this is just a revolution. This 360 degrees is a revolution. And then plus the acute angle theta, it falls in the first quadrant to give us the tangent of theta. Now let us look if we answer the question or not. They said that simplify P to a single trigonometric ratio. Is this a single trigonometric ratio? I believe not. So now we are going to work at it in such a way that we can ultimately find a single trigonometric ratio. There's a 3 trigonometric ratio, so they're certainly not single. So we're going to say that it's minus the sine of theta, the cosine of theta, because we can't do much about this, but this we can do something about. So we say it's sine of theta over the cosine of theta. But then now, what do you get to realize here? We realize that other trigonometric ratios can cross divide. So we can say that this cancels out that, and then you're going to be left with minus sine of theta times the sine of theta. And then you're going to have the minus sine squared of theta after multiplying these 2 times. And then we do know that this is a single trigonometric ratio because it's only sine. So that's how we can go about solving such problems. So moving forward, I want us to, perhaps just do more examples and just, get accustomed to doing the revision for trigonometry. So I'm just going to say that I devote this series of lessons to just revision before we can jump onto the actual metric content for trigonometry, because I think it's important for us to really just understand the basic part of trigonometry. So there's essentially just grade 10 and 11, just the difficulty level of this question is concentrated around grade 12 level, but it's essentially just the content that you did back in grade 10 and 11. So now I'm going to use a U sheet because I don't think we have so much space here. I'm going to use a U sheet for this problem. So now we are given that on this problem that if P is equal to the sine of B, beta, the sine of beta, beta, we all call it different, but I choose to call it beta. Express the following. The following is going to say FF in terms of P. So you're just going to say that the cosine of beta plus 360 degrees times the tan of beta minus 360 degrees times the cosine of beta plus 90 degrees over the sine squared of beta plus 180 degrees, the cosine of beta minus 90 degrees. So you're going to express this in terms of P, right? And we are given that P is just equal to the sine of beta. So now we also know that beta is an acute angle. And then this 360, which means that it's a revolution. So now we can say that this reduced is just going to be the cosine of beta, because in the first quadrant, we have all the trigonometric ratios being positive. And then you're going to now say deal with tan, and then tan B minus 360 degrees. B minus 360 degrees, just so we are not confused, because now we are used to it being written in terms of maybe there's the bigger angle coming on this side, and then the acute angle coming on the other side. So we're going to write it like we used to writing it. So I'm just going to say that now this is just equals to minus 360 degrees plus beta. And then I'm going to, okay, let me just write it like this, just so for the sake of consistency. And I should have done the same thing here so that I can write it in terms of this, but seeing that it's already done, let's just leave it as S. You guys will get the context of why I'm doing this, going forward. So this is just the sine squared, and then we have 180 plus beta, and then the cos. So this one is just going to be minus 90 plus beta. So now you must be flexible and really just get to think about your problems other than how you were taught. You must really think about your problems. If an angle, guys, if an angle is given in terms of a negative sign, then that means that, okay, let me just quickly show you guys here. So let me do this. If an angle is given as a negative angle, and then there's a Cartesian plane, we know that the angle is clockwise. It goes on clockwise level when it's positive, but a negative angle goes on anti-clockwise. Okay, a positive angle goes anti-clockwise, and then a negative angle goes clockwise in a clockwise direction. So now, if you're given something like this, minus 360 degrees, it only means that this angle went the clockwise direction up until the very first point. And now when you get here, we add with an angle beta, which is an acute positive angle, to this side. So now we know that, okay, tan in the first quadrant is positive, so it's just going to be tan of beta. And then we're going to have here, there's just 90 plus beta, and we know that in the second quadrant, only sine is positive. So now the cos is going to be negative. So I'm just going to put the negative here and put the cos beta here. And then how do you deal with this? This is quite different as compared to the examples that you've done in the past. So how we're going to just really solve this is that we can say, can we? So how we can just go around solving this, I'm just trying to think around it. Okay, while I think around it, let's just deal with this one over here. So the cosine of minus 90, so minus 90 is a clockwise angle, and then it's going to fall on the fourth quadrant. And then if we add by a positive angle of beta, we're still going to get the cosine of beta. And then when it comes to this one over here, you know that this can be written as the sine of 180 plus beta all squared. So you can write it in this way. So it's the sine of 180 plus beta all squared. I'm just going to put equals to sine here. And then we can just go further to say that minus the cosine of beta tan of beta cosine of beta over, and then we now are in a position to reduce this. So now when you reduce it, it's just going to be, we know that this, falls, 180 plus beta, it falls in the third quadrant. So if it falls in the third quadrant, we know that in the third quadrant, only tan is positive, which means that all the other trigonometric ratios are negative. So you're just going to say minus the sine of beta. But this minus sine of beta is squared. Shouldn't forget that. And then you write the same one. So now we look at what can divide, cross divide, and then we see that this can cross divide, and then you get to be left with minus cos of beta. But you also know that this can be written in terms of the sine of b over the cosine of b. And then this is going to be over minus sine of b all squared. So now, just since I'm running out of space, I'm just going to write the equal sign here. So this can also be written as the cosine of b times the sine of b over the cosine of b, and then divided. So it's just going to be divided by minus sine of b all squared. Sorry about the space. So I'm going to continue on the next page. So yeah, I can say that when I look at this, I already see that, okay, now this can cross divide that. And then I'm going to be left with the sine is equals to the sine. I just hope that you guys can see, okay, the sine of b. And then now we can change this one. We can say that it's times. But this one, sorry, this one is negative. This one is negative, considering that we had a negative sign here before we cross divided. And so if we say times, it's going to be 1 over the minus sine of beta all squared. And then we also know, guys, don't confuse it. We also know that if we say that this ratio is squared, then the negative sign is just going to go away, because it's going to be written as this here. Just let me just write it in full so that it can all make sense. It's going to be written as such, and then if we times this, then this is just going to be positive, and then you're going to be left with minus sine of beta over sine squared of beta. And then we know that this is just going to be the sine of beta. And then now, when you go back to this, let's put it nicely, the sine of beta, we substitute with p. We can say that, but just to illustrate understanding, sine of beta, p is equals to the sine of beta. And then we can say that now this is equals to 1 over p minus 1 over p. So this is our answer for that question. So guys, yeah, with all the variations of activities that you've done, this marks the end of our revision session. And on the next session that you're going to have, we are going to be dealing with the actual matric content going forward on how to solve things like your general rule, your functions, your trigonometric functions, and all those kind of stuff. So I'll see you next time, guys. Keep well.
Thank you so much, Keletso, for the lesson. It was insightful.
All right, I'm glad it was. Yeah, I guess for the next, because how many sessions have you done so far?
We've done about 4, 2 for maths, 2 for physics, and now it's 5 with trigonometry. So for the next couple of lessons, we'll just be on intense in the marketing and see how the turnout is. Because I feel like the real problem is the fact that schools are really having their learners work, a lot. And now learners have to choose in between like these tutoring services or school. So we'll definitely use the time to see what's the problem and try to fix it.
Okay, look, so I've only managed to cover the revision, ne?
Mm-hmm.
I don't mind doing like maybe like taking some time or from my days to continue up until the whole chapter of trigonometry is done. Ne?
Yeah. Mm-hmm. So you know what
So
we'll do from our side?
mm,
We'll just have to ensure that for sure we know there are students that are going to be joining so they can get the best value out of it. In as much as a recording is valuable, I feel like that interaction they can have with you. So we'll just try to see when are they available and work around that and work around your schedule as well to see when can we do this, because they are insightful when you're watching, but I think it's way nicer when you're able to engage with the tutor and
yeah.
ask questions. Yeah, but
Yeah, of
thank you so
course.
much for doing this.
No
Yeah.
no stress, no stress.
Yeah.
So what you guys can do, I don't know how you're going to work around this, but I'm asking that we
Mhm.
do more sessions so I can cover the whole trigonometry chapter. Ne?
Okay.
Because
Okay. Okay.
there's such a long chapter and it really needs.
Yeah.
So the next ones that you can guys do, maybe next weekend, to really just market this trigonometry,
Yeah.
trigonometry during the week, so that maybe I can do it next week. I can
Okay.
continue the sessions next week or even during the
Okay.
week. But as I don't know about during the week because it's always kind of hectic, you see. So
Yeah.
I
Okay.
I, I think over the weekends would work just so I can, because like I'm determined to just finish this chapter. Yeah, just so
Okay. That's
you,
amazing.
yeah, you guys have the whole content
Yeah.
to put up on RAM. You see.
Yes.
Mm.
And with your weekends, is it always mornings or sometimes are you available later? Or...
Look, you know what you guys can do, ne?
Mhm.
Thing is, you guys really need to work around how your customers feel, ne? Or how
Mhm.
your
Mhm.
potential customers feel. So you guys can make Google Sheets and say that would you rather have this session on
Okay.
in the morning or in the evening, and then what is your email address or what is your WhatsApp number, and then in that
Mhm.
you work with maybe 6 out of 10 or 8 out of 10 said that now
Yeah.
they want the lesson in the afternoon, and then you send all of those people that responded, WhatsApp
Okay.
text, direct messages, and just send them
Yeah.
the link and everything, you see. And then you
Okay.
guys can tell me well in time so that I can
Okay.
even like scrutinize my schedule so that it can
Okay.
accommodate the lesson, you
Okay.
see.
Thank
Yeah.
you. Thank you so much. We'll do that, and so is going to revert to you.
Come again?
I'm saying we'll do that until we'll communicate it to
Okay,
you.
no stress. Please send me the videos that the